This is section 3.5, equations of parallel and perpendicular lines. So in a coordinate plane, two distinct non-vertical lines, okay, so just two different lines that are not straight up and down, are parallel if and only they have the same slope. So takeaway from this part is that parallel lines have the same slope. Any two vertical lines are parallel. So any vertical lines are parallel to other vertical lines. When we talk about perpendicular, the slopes of perpendicular lines are negative reciprocals. Okay, so what that means is that if you have a slope of 2/3, our perpendicular slope, we flip the fraction and we change the sign. So if we had a slope of, let's say, -2, our perpendicular slope, well, the reciprocal of 2 is 1/2, and we change the negative to a positive. We can also say that any horizontal line is perpendicular to any vertical line. So we want to determine which of the lines are parallel and which of them are perpendicular. So let's start by finding the slopes first. So I'm going to look at the slope of line D. And I can count the slope of line D to be down 2 to the right 1, so that's -2. What about A? We have the slope of line A to be up 1 and to the right 4. Nope, up 1 and to the right 3, so it's 1/3. The slope of the line B is up 1, right 2, so it's 1/2. And the slope of line C is going to be up 1, right 2, so it's 1/2. Now that we know the slopes, let's figure out which ones are parallel and perpendicular. So for parallel, we're looking for lines with the same slope, which happen to be B and C. Those are the only lines with the same slope, so we're done with parallel. Let's look at perpendicular. The slope of perpendicular lines are negative reciprocals. Well, I know that -2 and +1/2 are negative reciprocals, so B and D are perpendicular, as well as C and D. So we're looking at the slopes and we are comparing them. Let's write the equation of the line passing through the point -1, 1, that's parallel to the line y equals 2x minus 3. So in the equation y equals 2x minus 3, we first start out by finding the slope. So if we think back to Algebra 1, y equals mx plus b, our m is 2. We know that we want to write a parallel line, so our slope is going to be 2. And then we're given the point -1, 1. And I like to use point slope formula. Some people like to use slope intercept form, but I like to use point slope. So remember that's y minus y1 equals m times x minus x1. So I just plug in what I know. So y minus, the y value is 1, equals m, which is 2, x minus -1, which is the same thing as x plus 1. And then I'm just going to solve for y. So y minus 1 equals 2x plus 2. Add 1 to both sides. I get y equals 2x plus 3. So that is the equation of the line parallel to y equals 2x minus 3 through the point -1, 1. All right, and then let's look at the next one, right? The equation of the line passing through the point 2, 3, that's perpendicular to the line 2x plus y equals 2. The equation that they give us is in standard form, so we could either solve it for slope-intercept form by subtracting 2x from each side, so we get y equals -2x plus 2. Or you can use the trick that you learned in Algebra 1, that the slope of a standard form line is -a over b. Either way, this might just be a little bit more familiar to people. Our slope here is -2, and we want to be perpendicular. So we want our perpendicular slope to be the negative reciprocal. So it's going to be positive 1/2. Then I'm going to use my slope or point slope form again. So y minus 3 equals 1/2 times x minus 2, and solve for y. So 1/2 x minus 1, add 3 to both sides, y equals 1/2 x plus 2. So that is the equation of our perpendicular line. So remember, when we're finding the distance from a point to a line, we look at the perpendicular segment. Okay, so we want them to be perpendicular. So knowing that, we're going to find the equation of the perpendicular line through the given point. So we're trying to find the distance from point P. So we're finding the perpendicular line through point P to the line that we're given. Use the two equations to write and solve a system of equations to find an intersection point, and then use the distance formula. All right, I understand that that sounds like a lot, so let's do an example. Find the distance from the point 1, 0 to the line y equals negative x plus 3. So if we want to look at this, what it would look like on a graph, let's draw it. So here's my graph, poorly drawn. We're looking at the point 1, 0. So it should be right there. We're looking for the distance from that point to the line y equals negative x plus 3. So my y-intercept is 3, slope is negative 1. So we're trying to find the distance between that point and that line. We're going to find that perpendicular distance. So we need to find the equation of this line, because we need to find where these two lines would intersect. So let's start by finding the perpendicular line through the point 1, 0. So the slope of this line is negative 1. So our perpendicular slope is going to be positive 1. Then we do the same thing, so y minus, our y1 is 0, equals m times x. Or whoops, I can even fill in numbers. So we have m is 1 times the quantity x minus 1. Well, y minus 0 is just y, and then we get x minus 1 when we distribute. So this is the line y equals x minus 1. I want to figure out where those two are going to meet. So I'm going to do a little bit of solving a system of equations by substitution that we learned, because I'm trying to find where these two lines are equal. So I'm going to take this and set it equal to this, because we want to find where they're equal. So negative x plus 3 is equal to x minus 1. I'm going to add x to both sides and add 1 to both sides. So we get 4 equals 2x divided by 2. X equals 2. So those two lines meet at x equals 2. Let's find the y value. Okay, you can plug x into either of our two equations to find your y value that matches with it. So our y, I'm going to pick the first one. So negative 2 plus 3. Negative 2 plus 3 is 1. So our point is at 2, 1. Obviously didn't draw that very well. So we know that the line we're given and then this perpendicular line are going to intersect at the point 2, 1. So we're trying to find the distance between the point that we're given and the point that we just found. So that means distance formula. So the distance between that 1, 0 and 2, 1. So we take x2 minus x1 squared plus y2 minus y1 squared. So the square root of 2 minus 1 is 1. 1 squared is 1. 1 minus 0 is 1. 1 squared is 1. So we want the square root of 2. And if you want to go ahead and type that into your calculator to find the actual square root of 2, we find that the distance is about 1.4142. So that's the distance from the point 1, 0 to the line y equals negative x plus 3.